Page 358 is applied
Is that the right one? All right, page 359, sorry. Okay, so when you write things out with the addition signs in the middle, it's called a series. We're summing this series. We're going to learn how to write it in a shorthand using what's called sigma notation, which is the Greek letter sigma. And it comes from, they use sigma because S sum sigma. You'll see it again in calculus, okay? So here is the notation. First of all, you got this big letter E. This is the formula to get the terms, all right? This is your starting point. They call it the lower limit, all right? You start at the one at the bottom and you go to the upper limit. So you keep subbing in 1, 2, 3, 4, 5, 6, 7, 8, okay? All right, they all have to be whole numbers. All the k values, sometimes it'll be called an I or n, all right? The variables are relevant, but these are all natural numbers. They're always whole numbers. They're never negative. They're always whole numbers, okay? So if I give you this notation, so I would read this as the sum from 1 to 8 of 2 to the power of k. We're going to write it in expanded form. So you plug in 1 first. If I put 1 into it, I get 2 to the power of 1. And because it's a sigma, that means we're summing it, so it's a plus. And then you write the next term. You put k is equal to 2 into it. So I get 2 to the power of 2. I'll rewrite them in actual numbers after this in a sec. And then it's 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7, 2 to the power of 8, which you could just write as 2 plus 4 plus 8, 16, 32, 64, 128, 256. No, you can go to infinity. All right. And then you basically just add them all together. Now, this one, you could literally just add them all together. And if you added them all up, you'd get 510. Or what you could do. Okay, does that make sense? All you do is you start with the lower one, you put it into the formula, then you put the 2, the next one, all the way up to the upper. And then you add them, because that's what sigma means, sum them all. You could have just figured it out from the first few as a sequence where A is equal to 2. Your R value is equal to 2. And you know the last term is 256. So you could have just used the formula Sn is R Tn minus A over R minus 1. And I would recommend using the formula if there's too many terms, right? If our upper limit was like 50, I'm not going to write out all those terms, okay? I would just write the first few so that you know A and R and plug it into the formula. How many terms are in this series? 8. Count them. 1, 2, 3, 4, 5, 6, 7, 8.
I was thinking of something.
There's 8 terms in the series, okay? Does that make sense? That's what a sigma means. It means you just plug in the numbers and add up all the terms. That's all it means. Okay? Can I move to the next page?
Yeah.
All right. So let your k value or your I value or your n value, your lower limit, does not have to be 1. It can start at a different number. In this case, it starts at 5. So if we're going to write this in expanded form, you start by putting 5 in. So we're going to get 5 times 2. If I put 5 into the exponent here, what's 5 plus 1? 6. There's our first term. Plus, then put in 6. 5 times 2 to the 7. 5 times 2 to the 8. 5 times 2 to the 9.
So there's 4 terms in this one.
Why do you go 9?
Yeah.
Because I put 8 in. 8 plus 1 is?
That sounds illegal.
Right? You're plugging your k values into this.
Yeah.
All right? That's why we started 6 and then 7, 8. Okay? And then if they asked you to sum them, well, 5 times 2 to the 6, I'll just tell you what these answers are.
So you put the k value into k and also the 8 value.
Yeah, from the lower k to the upper k. You're summing all those terms. If you add those all together, you get 4,800. Okay. How many terms are in this series? 4. So to get the number of terms, all you do, well, the formula is right at the bottom there.
5 minus 1. 8.
The upper limit minus the lower limit. 8 minus 5. And then you add 1. Okay? That's how you find the number of terms. I know. All right. Is that okay? Sigma means you're adding everything together. So you literally just plug in the k values, put a plus between each term, add them all together. Is that okay? No? That's to get to the number of terms.
Oh, okay.
Right? Upper limit minus lower limit plus 1. All right. So now we can work backwards. If I give you the series, we can write it in sigma notation. So here's our geometric series. What's our A value? What's our R value? 1/2. Does everybody agree with that?
Or 2 to the power 1.
Okay. Now, the formula for a geometric series is ARn minus 1, correct? So if we plug those in, I get 3 times 1/2 to the n minus 1. So if I want to write this in sigma notation, I write a sigma. I put our formula inside of it. What do I write for my upper and lower limits? N is equal to, what's my lower limit? It'll be 1. Because if I put n is equal to 1 into here, right? What's 1 minus 1? 0. What's anything to the 0 power?
1.
1 times 3. So my first term is 3. It has to match that. Okay?
That's kind of like weird. Like,
That's really smart.
I don't know what to say. What's my upper limit? 4. 6. How many terms are there?
Whoa, 6.
1, 2, 3, 4, 5, 6 terms.
All up.
So check your answer though. If I put 6 in, what's 6 minus 1?
5.
5. What's 1/2 to the 5th?
1 over 32.
1 over 32 times 3 is going to be 3 over 32. Okay? So you can always check your answer. All right? All right. Is that okay? Rewrite it as AR to the n minus 1. Put that in. Your lower term number is n is equal to 1. It'll always be n is equal to 1 when you're making it. Okay? When you're given this and you're going to put it in, n will always be 1 unless I make some weird question. But obviously, as we discovered at the beginning of class today, if I go off book, I usually box the question. So we won't do that. Okay?
The bottom one ends in 0.
I know. That's okay. So always start as n is equal to 1 and then just count the terms and that's what goes there. All right, next one. Determine the value of this whole sequence. So first of all, it's 0 to 20. How many terms are in this?
21.
It's upper limit minus lower limit, right? So the number of terms is going to be 20 minus 0 plus 1. So there's 21 terms in this sequence. We know it's going to be geometric, so you only have to find the first two terms, and that'll give you A and R, and we can sum it after that, okay? So the first term is T1. What number do I plug in first for K? 0. You start with the lower limit. So I'm going to get anything to the 0 power is? So I just get 5. That's your A value. That's A. Now you got to find second term. So you put in K is equal to 1. So I get 20 over 3.
Wait. If there's only k out of the bracket, we can just say that our value is put inside the bracket.
That's right.
Oh, shit.
But it's not always going to be like that.
Sorry?
It won't always be like that.
Well, if it's
You'll-
only,
You'll see on the next one.
if it's only
You see-
k,
You'll see on the next one. All right. So what's our R value? It's 4 over 3. That's what you're multiplying by. Okay? So our R value is 4/3. All right. If I want to sum this series, I need to know the number of terms, which we just figured out. So that's our N. What formula am I going to use? Yeah. The one where you don't know the last term. Sn is equal to A R n minus 4 R minus 1. That one. So S20 is going to be A, which is 5.
Well, I thought it's 21.
Oh, thank you. 21. All right. This will be a challenge for people because it's got fractions.
6,000.
But you can just do a decimal. Just go 4 divided by 3 and do everything that way. I know what it is. And tell me the sum, please. To, what do they want? Nearest 10th.
6,221.7. Here, I got you.
Do we have it?
Yeah.
6291.7? All right, one more with 3 parts, but it's not too bad. Okay. Ready, set? Okay. All right. Now we have a sequence defined by this formula. The first term, t1 is equal to 3. Every other term is defined by t of n is equal to 5 times t of n minus 1. All right, list the first 4 terms. So t1 is 3. They tell you that. t2, you have to use this part of it because it's when n is greater than 1. So if I put 2 into there, I get 5. If I put a 2 there, 2 minus 1 is 1. What's t1? So it's 5 times 3. So the second term is 15. Does that make sense? All you do is put t2, put your n value into there. We're going to do the next one. Let's do t3. t3, that means our n value is 3, right? So I go 5 times t, I'll even write it out, 3 minus 1. What's 3 minus 1? So it's 5 times t2. What's t2? What's 5 times 15? No. All right. Tell me what t4 is, please. Freeze it, freeze it, freeze it, freeze it, freeze it, freeze it.
375. What? 375. No, he's not.
375.
What's 375 over 5? Come on, man.
What is t4?
375.
375.
25?
What?
1875. Yeah.
What?
Oh, he's talking about term 5, right?
Yeah.
Oh,
He's already on 2 terms.
they only want the first 4.
Like no.
If you want to do extra work, do that. But okay. Find the sum of the first 12 terms. Do I know the last term? No. But I know n, which is 12. Do I know a? 3. What's r? 5, right? Because you're going up by 5. I went from 3 to 15 to 75 to 375. So S is going to be A r to the n minus 1 over r minus 1.
That's supposed to be S.
Yeah, that's SN, sorry. I always forget the n.
Is that right, Mr. Bowman?
Freeze it. So I can write mine up. What does that represent? Or sorry, what is the number? It should be a big number.
183 million, blah, blah, blah. 175.
183,105,468.
Yeah.
You got right, man.
Thank you, Dante, for validating me. Everybody agree with that?
Yeah.
Okay, last question. Write this series in sigma notation. Actually, I'm going to let you try it. So that means where you have to put the sigma. You already know A, you know R. What's your A value?
3.
Maybe take it off, yeah. It's 3, so it's going to be 3. What's your R value? Times 5 to the n minus 1. You always write it as ARN minus 1. What's my n value, or K, or whatever you want to call this? Let's call it, yeah, n. You always start with 1. Nope. You would go to 12. Because what's 12 minus 1? 11 plus 1 gives you 12 terms. So always go from 1 to whatever.
Wait, why did we get 12? No way.
Because it's the first 12 terms.
How do you do it?
All right. And this,
I think that's all the terms.
no, it's just the first 12 terms. Because that's what we were summing, right? Sigma means sum. So the answer, technically, is the answer to that sigma notation. That whole thing equals 183,105,468. Okay? All right.
Thanks, Baldwin.
You're welcome. Here's your questions. I know we're right at the end of class time. We only have one more lesson tomorrow.